So we're going to start this lesson by looking at just how you solve equations that have squares in them by taking square roots. So it says solve each equation by taking square roots. So I have m squared equals 81. The opposite of squared is square root. So I square root both sides. Now what's going to be a little different than what we've done with these in the past is I have to think about there's actually two answers. There's 9 or there's negative 9. So the reason why there's 2 is because if I take 9 and square it, it's 9 times 9 is 81. If I take negative 9 and square it, that's negative 9 times negative 9, which is still positive 81. And there's a special shorthand for writing both of these. If I don't want to write 9 or negative 9, you can do this, plus or minus 9. And that means you get positive 9 and negative 9 in one neat little short thing, which we like because then we don't have to do a whole lot of extra stuff. Okay, so
is that even possible?
It is possible, and we've done this before a little bit. If I square root these, so Gracie's looking at this going, can we take the square root of a negative? And the answer is yes, if we use I, imaginary numbers. So I have to think of this as the square root of 30 and the square root of negative 1 and break it apart. Now 30, if you look at it and try to do a birthday cake with 30 in prime factorization, it's actually not going to reduce at all. There's no numbers there, so we're just going to call it I square root of 30. Or 30 square root of I, but they like having the i's out front. So if there's a negative there, you're just going to add an I. It doesn't really hurt anything. And then if we have a square root that we can simplify, we'll do that too. So let's go down to number 3. So number 3 has a 5 in front of the x squared. We just treat it like you would a normal equation. My first step would be to get rid of that 5 by dividing both sides by 5. And that's nicer anyway because then I get x squared equals 4. And that's going to be an easier number to work with. So to get rid of the squared, we square root. And we just need to remember there's two answers. I am off the screen. Let me move that up. So the square root of 4 is plus or minus 2. And I can't draw a straight line, but it's fine.
It's Friday.
It's Friday. Okay, so let's look at number 4. Try to get that on the screen. So before I square root, I need to get rid of plus 9. So I subtract 9, and it is going to look a little weird because I'm going to have a squared equals 0. But this one's kind of a cool one. When I square root 0, there really isn't positive and negative 0. It's just 0. So we get to just say it's 0, and that's it. All right, let's move down to number 5. So we've got a couple of things to get rid of to get the n squared by itself. What do you guys think we should do first?
Plus 3.
Plus 3. So we're going to add 3 to both sides. That gets the term that has the n squared in it by itself. So 2n squared equals 162. And then what do we do?
Divide by 2.
Divide by 2. And I'll get n squared, if I can write, n squared equals 81. Am I done?
No.
No, so the very last step is to get rid of the squared by square rooting both sides and get plus or minus 9. All right, so everybody good? I don't know if we need, well, I'm probably forgetting something. Oh, yeah, there's some special cases. Let's look at number 6. So on number 6, we would add 5 first. We'll have 36n squared equals 25. And then we have to divide by 36. And I'm going to tell you to just leave it for a second as 25 over 36. Because when I square root, I just have to square root the top and square root the bottom. So the square root of 25 is 5. Square root of 36 is 6. And then we have plus or minus.
Do you have to make plus or minus?
Yep.
Negative.
Because it can have two answers. A lot of the equations we're going to do when we look at quadratics are going to have two answers. And that's because most of the time, so what he's asking about is the plus or minus. And so when we did our parabolas, a lot of them cross the x-axis in two places. And sometimes it's a positive negative. So let me show a picture that would look like that. If you have one that goes like this, which all of these would, you're going to have your positive x-intercept and your negative x-intercept. And so that's the graph that corresponds with these answers.
So how do you graph that on the calculator?
Well, for this, they're only giving us, we would have to move this over here, and we'll get into that more in the next lesson. We do vertex form, which we will be completing the square and lots of other things. So it's coming. It'll make more sense when we put the y back in there and complete the square, but those are excellent questions. But just the short answer is the ones on this page are pretty much centered on the y-axis, and you have a positive and a negative where it crosses, and that's why you have to. It's because it crosses in two places. Otherwise, it'd be a straight line, and it would be different. Okay, so let's see what else there is. On number 7, we need to add 8 to both sides first, so I get 9m squared. And then I got to think for a second. 864.
Yeah.
And then divide by 9.
96.
And you get 96. Okay, so 96 is not a perfect square number. So what we're going to do with that is birthday cake, everyone's favorite. We had cupcakes today. So just to start, we know how to do this. We've been doing it for a couple of years. So what's a prime number that goes into 96? It's even.
2.
So 2, good job. And then we have 48, it's still even.
2.
So 2, 24,
2.
2, 12,
2.
2, 6,
2.
2, 3, and then finally you get something else. So this is the birthday cake method of doing prime factorization. So I have a 2 and a 2 that can be written as 2 squared and 2 squared. I've got a couple of pairs. And so when I square root this, I guess I got a little ahead of myself. When I square root this, and I need to simplify it, I'm going to have 2 times 2 on the outside, and then 2 times 3 on the inside of the radical. I need to remember my plus or minus, and then I have 4 radical 6. I forgot all these lovely details.
You're out of the screen again.
I am off the screen again. Let's scoot that up. So the numbers that were pairs, I can write that as 2 squared and 2 squared. So if we square root that, that's 2 times 2. The other numbers didn't have a pair, so they're still locked inside the radical, and that's how you get the simplified version. All right, one more, and I think we'll probably stop for today. So if we add 10 to both sides, we get 9k squared equals 180. So divide by 9, divide by 9, I get k squared equals 20. Now the good news is 20 is not as big a number. So when I square root it, I'm going to have plus or minus, and then I'll birthday cake 20. So divide by 2, I get 10. Divide by 2, I get 5. Divide by 5, I get 1. Am I? I am off the screen. I apologize. I don't know. I think it's not centered today, and I just don't know where to put my book. So we just took 20 divided by 2, got 10, divided by 2, got 5, divided by 5. Got the birthday candle on the top. I get to 1, we know we can stop. And so I have a pair of 2's, that's 2 squared. If I square root that, that's 2. 5 goes on the inside. I've got the plus or minus. And that's it for the first half of this lesson.